Hello everyone. Our today's A-level chemistry topic is Group 17. Group 17 in the periodic table is named as halogens, means salt forming. The member of Group 17 are fluorine, chlorine, bromine and iodine and astatine. Astatine is a radioactive member, that's why its chemical reaction is not available because all radioactive substances are short-lived and after decaying or after emitting different types of radiations they convert into another new elements. So these elements are called as halogens because they form salts whenever they react with reactive metals. At the normal condition of temperature and pressure, these exist as a diatomic form, diatomic molecule. Discrete diatomic molecules are formed by all these group 17 elements: fluorine, chlorine, bromine and iodine. The first two members, fluorine and chlorine, both of these are gases, while bromine is present in the liquid state and iodine is present in the solid state. If we consider their color, the color of the fluorine is pale yellow. The color of chlorine is greenish yellow or the mixed shade. The color of the bromine is brown, red brown, and the color of the iodine, which is present in solid state, that is a shiny black. But if it changes into vapors, its vapor is of purple color because solid iodine shows sublimation. Whenever solid iodine is heated, it directly changes into vapors without melting. Now, as we go down from top to bottom, the color of the element becomes darker and darker. On the basis of their proton number, the proton numbers are of fluorine 9, chlorine 17, the difference is of 8. From chlorine to bromine with 35 proton number with bromine, difference is 18. And then from bromine 35 to iodine 53, there is a difference of another 18. And then from iodine to astatine, there is a difference of 32. In this manner, we can easily find out the proton number of the element on the basis of this formula. Now, if we show the electronic configuration, the fluorine electronic configuration is 1s2 2s2 2p5. Then for chlorine, 1s2 2s2 2p6 3s2 and 3p5. It means that all the last electron of halogens enters into the p subshell. That's why all these halogens members are called p block element. Now, as only one electron is short for the completion of their last shell, that's why all these are non-metals, and try immediately to accept one electron to complete their last shell. By accepting electron, it is quite clear that all halogens act as an oxidizing agent and their oxidizing power from top to bottom decreases. The maximum electronegativity of fluorine is in whole of the periodic table, which is 4. which is standard 4. The electronegativity of chlorine is 3. The electronegativity of bromine is 2.8 and electronegativity of iodine is 2.5. It means that according to the definition, what is the electronegativity? Electronegativity is the power of an atom to attract a shared electron pair between atoms towards itself. This is called as electronegativity. As fluorine is highly electronegative, it means that the power of a fluorine atom to attract the electron is maximum. That's why we can say the fluorine is the strongest oxidizing agent. While as the electronegativity of iodine is 2.5, which is the least, that's why it applies lesser force of attraction to attract electron. That's why this will act as a weak oxidizing agent. Now, all these members exist, as I have discussed, as a discrete molecules. Between molecules, weak intermolecular forces are present. So, due to the weaker force of attractions, their melting and boiling point are lesser as compared to other. Now, their reduction potentials is always positive and act as a good oxidizing agent whenever these halogens take part in a chemical reaction. Now, if we discuss the reactivity from top to bottom, from fluorine to iodine, the reactivity of these halogen elements decreases. Fluorine is the most reactive, chlorine is then less reactive, bromine less reactive, and iodine is further less reactive. Now, if we consider their chemical reactions, these halogens show displacement reactions. These halogens show displacement reactions. Displacement reactions. What does it mean? It means that whenever a topper or upper halogen is passed through the solution of lower halogen salt solution, for example NaBr aqueous. If we pass chlorine gas through sodium bromide aqueous solution, what will happen? Its color is greenish yellow, light green yellow. But when we will pass the chlorine through sodium bromide, which is a colorless, immediately due to the bromine, red-brown color will appear and reaction will take place just like this: NaCl and plus Br2. Due to this production of Br, the solution turns from colorless to red-brown due to the production of the bromine. It means that chlorine has displaced this bromide ion from its salt solution because the reactivity of chlorine is more as compared to bromine. That's why chlorine easily oxidizes bromide ion and convert this bromide ion into bromine gas or liquid, which produce red-brown color, which indicate that in this manner reaction will take place. The upper halogen will displace the lower halogen from its salt solution, but the lower halogen cannot displace upper halogen from its salt solution. For example, if we add aqueous bromine into NaCl HCl solution, no reaction will take place. Nothing will take place, and the color of the bromine red brown will remain as such into the solution. This indicates that lower halogen cannot displace the upper one. Similarly, if we pass through sodium iodide solution, either fluorine or either chlorine or either bromine, all these are upper than the iodine. That's why all these halogen can displace iodide ion from the aqueous solution into iodine and form a chemical reaction. As a result, color change will take place. If fluorine reacts, what will happen? If fluorine reacts, as pale yellow color of fluorine is there, that is very faint. As a result of chemical reaction, sodium fluoride will form and iodine will be produced. Due to the production of this iodine, the solution will be observed as brown. The solution will change color from colorless to brown. If we pass coloring, same color change will be observed. But if we pass bromine through sodium iodide solution, then it will produce sodium bromide along with iodine. Now, what will happen? The color of the bromine is red brown, but this solution will show brown color due to the production of iodine in aqueous solution. So, in this manner, we can say that halogens perform displacement reactions. Upper halogen can displace the lower one from its aqueous salt solution, but the lower halogen cannot displace the others. I have explained the introduction, electronic configuration, existence, color, and the other spectral properties of the halogens. Please comments, like, share, and subscribe my YouTube channel for the next upcoming videos. I thank you all.